Hey everyone, and welcome. Today, we're going to dive deep, and I mean deep, into the engine room of a ship. We're going to explore a really critical piece of technology that protects our oceans, the oily water separator. And just so you know, this whole explainer is based on the fantastic work of Dr. Sameh Tawfik. It's a fascinating look at how we keep our seas clean.
So here's our game plan. First, we'll figure out where all this oily water on a ship even comes from. Then, we'll get into the super strict international rule that says what you can do with it. After that, we'll peek inside the separator to see the clever tech at work. We'll follow the water's entire journey. And finally, we'll talk about the crucial human side of keeping our oceans pristine. All right, first things first, where does this oily problem even begin? Well, it turns out that every big ship out there, just by doing its job and running its engines, creates this messy byproduct that has to be dealt with very, very carefully. And that stuff is called bilge water. I want you to picture a ship's engine room for a second. It's this beehive of activity, right? You've got pumps running, engines vibrating, and crew washing down equipment. Well, all that action inevitably leads to tiny leaks of oil, fuel, and lubricants, and it all mixes with water, creating this oily sludge. Now, this whole mixture gets collected in something called a bilge holding tank. And here is the most important part. You absolutely positively cannot just pump this stuff overboard. I mean, doing that would be a total environmental disaster. It would wreak havoc on marine life and fragile ecosystems, so obviously ships need a way to clean it up first. And that brings us to the rules, because to stop ships from just dumping this waste, there are some serious, legally binding international standards that say exactly how clean that water has to be before it can go back into the sea. The main rulebook is an international agreement called the MARPOL Convention. You can think of it as the global law for preventing pollution from ships, and it applies to pretty much every large commercial vessel out there. Any ship over a certain size has to follow these rules, no exceptions. It's the worldwide standard. And right at the heart of this whole regulation is one little number, 15 ppm. That stands for 15 parts per million. To give you some perspective, that's like taking 1,000,000 drops of water and allowing only 15 of those drops to be oil. It is an incredibly tiny, tiny amount. In fact, the regulation itself is crystal clear. This quote basically means that the water leaving the ship has to be so clean, it's got practically zero oil in it. If it's even a tiny bit over 15 parts per million, that discharge is illegal, period. So the big question is, how on earth do you get water that clean? To hit that unbelievably high standard, we've got to go inside the machine that makes it all happen, the oily water separator, or OWS for short. The whole system works on a beautifully simple idea: gravity separation. Come on, we all know oil and water don't mix, right? You've seen it in salad dressing. Because oil is less dense, it always floats to the top of water. The OWS is basically just designed to use this basic law of physics in a really smart way. What's really clever, though, is how the separator is built to speed up that natural process. So have a look at this diagram with me. The oily water comes in on the left and immediately hits a grit trap to filter out any solids. From there, it flows into the main chamber, and that's where the real magic happens. As the water moves through, those little droplets of oil naturally start to rise. But here's the genius part: this assembly of parallel plates. These plates create a huge surface area, which encourages all the tiny oil droplets to bump into each other and merge into bigger and bigger blobs. This process is called coalescing. It's just a fancy way of saying they team up. And once they're bigger, they rise way faster, forming a thick layer of oil at the top that can just be skimmed right off and sent to a sludge tank. So that's the core principle, right? Pretty cool. Now let's zoom out and look at the whole system, and we'll trace the water's path from that dirty bilge tank all the way to its clean release overboard. This flow diagram shows you the whole setup. Oily water gets pumped from the holding tank into the main separator. Like we just saw, the oil gets separated out and piped away. Meanwhile, the now much cleaner water flows out from the bottom to get a final polish. But the journey isn't over yet. Before a single drop of that water can be discharged overboard, it has to pass one final supercritical checkpoint, the Oil Content Detection Monitor, or OCD monitor. This thing is the system's watchdog. It's constantly sampling the water, and if it ever detects an oil content above 15 ppm, an alarm goes off and a valve slams shut automatically. It stops the discharge and sends the water right back to the beginning for reprocessing. It's the ultimate failsafe to prevent pollution.
So, look, the technology is fantastic. There's no doubt about it. But it's only half the battle. To really, truly prevent pollution, the ship's crew has to follow some incredibly strict procedures. Because at the end of the day, technology is only as good as the people who operate it. And this is where diligence just becomes absolutely critical. Every officer on board needs to be an expert on those MARPOL regulations. Every single transfer of oil or bilge water has to be logged meticulously in the official oil record book. And maybe the most important thing of all is just good maintenance. Preventing leaks in the first place is the best way to cut down on bilge water. It's simple. A well-maintained ship is a cleaner ship.
So when you step back, it's pretty incredible. This gravity-based separation tech has been the backbone of protecting our oceans from ships for over half a century. It's reliable, it's effective, but it really makes you wonder, right? As we look to the future with new kinds of fuels and probably even stricter rules, what kind of innovations will lead the way for the next 50 years?
And that brings us to the end of our journey into the oily water separator. We really hope this gave you a clear look inside this essential piece of marine technology. This analysis was all made possible by the foundational work of Dr. Samet Tawfik. Thanks so much for watching.